What's up, y'all? I'm about to show you my LeetCode solution for the second LeetCode problem, add two numbers. So first we need to go over the problem. It says you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. Okay, so the main thing about this is we need to understand how linked lists work. If you don't understand linked lists, this problem is going to be very, very hard. So you'll definitely want to take time to study linked lists, and you'll see up here they help us out a lot. They give us their definition for a linked list, and their definition for a linked list is very, very simple, so that's good. And I'm going to pause here to kind of talk about linked lists, but I'll show you on my VS Code, but I dragged this down here, and linked lists as a data type, they have no index or anything like that. They're only connected together because they know what the next node is, and as you'll see here, a linked list only stores two things. It stores a value, and it stores whatever the next value is. So the way these connect together is not it's not as easy to find things as like an array or a list where things are indexed. Same with strings, things are indexed. So there's no index or anything like that here, so it kind of makes things tough, and it's not really that intuitive of a concept at first. At least it wasn't for me. And so right here we have the list nodes. So I have 2, 4, and 3, and then I'm just saying L1.next is list node, and it just kind of chains along like this, and it only knows by what's ahead of it. So it just, I know that there's something in front of me. Okay, cool. There's nothing in front of me. All right, the list is done. So it's not it doesn't have very much metadata about itself. So that's something that that's good to consider when working with linked lists. But let's finish going over the question. So it just shows us the it just shows us some examples. So we just take this, flip it around, take this, flip it around, do the math, add it up, return the result that is reversed as well. So there's a little bit of reversing and finickiness, but overall it's a very simple problem. It's just you're not working with a simple data type. You're working with a very complicated, tricky data type that does not normally come up in, you know, your regular everyday coding. So that's what makes this tough. So what I did here first is I instantiated two linked lists. So how do I want to do this? I already have all the solution here. It's going to print everything out. I might just maybe or let's see if that works. I don't have this in a function. I'm not sure if that's going to work. But let's just print L1. Okay. You know, whatever. I'm just going to let the whole thing run. You guys will get the picture. I don't feel like commenting the whole thing out. I know that I can import something from sys that will cause a breakpoint to come in here. I just don't feel like doing that right now. So, but yeah, this accomplishes what we're doing. So we get this object here. That's good. And then we're going to say, all right, we want L1.value. We got to get the value out of the object. You know what, actually, doi That's what I get for doing this stream of consciousness and not planning it out more, but doy, I can just comment out the print statements. Okay, there we go. Now we get 2. And we can also grab whatever is next. So we can say next, and then we will get a different object, and that different object will have a different value. We'll get that 4, and then we can add another next and get that value. So that should at least provide a little bit of intuition for how linked lists work. But yeah, when we do this, we're going to have to pull the data out of these linked lists. Sorry, I gotta scratch my nose here right quick. See if I can turn off my camera right quick. Sweet. Still caught a little bit of it, but that's fine. Yeah, back here. Okay, so in order to pull all this data out of these linked lists, we're going to have to iterate through the linked lists. And that's what we do here. So how do we iterate through it? We can't, it doesn't have an index. We can't just do a for loop through it. That's not going to work. We're going to have to go through it in such a way where it checks the first node, then it looks, is there a next node? Okay, we'll go, then we have to travel to the next node and kind of hop along one node at a time. So how do we do that? That's not really an intuitive thing, and if you don't look this up or see this, this is not super intuitive, but what you do is you just say while, in this case L1. So while there is a list node. So while this exists, it's going to say while that's true. And then I'm doing some math here too. I'll explain this math too, but what we're really doing here though is we're saying, okay, L1 is equal to L1.next. So we're saying while L1 exists, L1 is going to move to L1.next, and this is how we iterate through and hop along through a linked list. We have to use a while loop. And then I'm just grabbing the value as an integer here. I think this is the simplest and most efficient way to do it, so just a good little mathematical hack. So I start here with I1, which is equal to 1, and then N1, which is equal to 0, and I1 basically measures the amount of iterations that we go through here, and we use that in a mathematical formula right here, which basically takes the value and then multiplies it by I1, and then I1 is going to be multiplied by 10 every time we iterate through here. And what that essentially does is this first value goes in the ones place, second value goes in the tens place, third value goes in the hundreds place, and real quick I want to jump over to the problem again, and we can have up to 100 nodes. So we could be jumping into the millions up there. Millions, the billions, whatever, very high numbers. And it will just turn it into a number which we print out here. So we're going to print out N1. Let's stop printing this out, but it has done the math and it has given us the reverse of this, which is what we wanted, so that's great. We're going to do the same thing for N2. Boom, that's great. We also got the reverse here, 465. That's awesome, just using this nifty little while loop thing. We got the values into integers. So that's awesome. And now we're going to do the sum. And we're going to add the two values up to get our result. Then we're going to use some list comprehension to turn that result into an array, into that array that we want that has the results reversed. And if you don't know list comprehension, essentially what we're doing here is we're saying str sum, we're going to say, I don't know, sum is equal to str sum, and then we're going to say for I in str, or for I in sum, and then we're going to say, res is now equal to this. And we're going to say res dot append I. So just instead of having to write all that out, it's just we pop it all in here, and it's a lot quicker, but it's doing the same exact thing under the hood. So just so you know what this is. This is just a little Python thing just to make things more concise. So for simplicity's sake, you can just look at this, but that's all we're doing. We're just going to turn it into a string and then iterate through that string, because numbers don't have indexes. So this sum is an integer. Integers have no index, so we have to turn it into a string so we can get an index. And then, but we're turning it back into an int too also, which I skipped that. So then we're turning it back into an int, and this is just a nifty little piece of code. I like it. It's very concise. It's awesome, so I'm using it. I think I grabbed it from Stack Overflow, so it is good. I like it, so that's what I'm going to use. So boom, now we have that list, and we reverse the list around, and I'm just going to print that list out. Okay, perfect. So we have what we want. I'm also going to comment that out. Perfect. We've got what we need. But now this next part is pretty complicated, because we're going to have to take this and we're going to have to turn it back into a new linked list, and that's going to be kind of annoying. So how are we going to do this? We're going to have to establish a head. So the head is going to be the right over here. The head is going to be this first index of res. And then we're going to make another pointer that's going to point to this exact same object. And this is kind of unintuitive, but this is the only way to really make this work. And this is something where if you haven't seen it, it's going to be hard to figure it out. So then we're going to iterate through that array, cutting off the first indice. So we're going to cut this 7 off and just go through the 0, 8. And then we're going to set that iterator.next to the list node of I. And then we're going to set iterator.next to iterator.next. And essentially what this does under the hood is iterator.next and head.next is going to equal the same thing, and head.next is going to persist, and then iterator.next is going to crawl along. So iterator.next is going to set this here, and then it's going to crawl to here. But if we don't separate it out from head, then our linked list is always just going to be the tail node and the node before it, because that chain won't get persisted, because iterator.next will just like go from 1, 2, 1, 2. So we have to have that head so the chain will persist. Not a super intuitive concept, not a concept I would get on my own, but that's how we do it, as tricky as that is. So hold up a sec. I've taken this and I've moved it over to LeetCode. So we're in LeetCode here. I have the solution in here. I've added it into this function, but the same thing is here, and instead of returning head, we're going to print head. Or instead of printing head, we're going to return head. So we're going to run it. Amazing, it works. Now we're going to submit it. Hey, alright. We beat 93.93%. This is really good. So okay, my memory though, it uses up a lot of memory, so, but did good on the runtime. So that's good. And if we go back to the code right quick, we can look at the runtime complexity. So there's not really a lot, there's no like loops inside of a loop or anything like that. This is all just regular O of n runtime. There's not even an if statement inside of a loop or anything like that, so this runs pretty efficiently. It does have a lot of variables though too. I could give the variables shorter names or something, I don't know, but I'm pretty happy with what I have here. So thank you all for watching. Happy coding. I hope this helped you understand this. I hope this made it more intuitive, and yeah, good luck out there with your coding, and I'm out of here.